Hello and welcome to our webinar on stock and custom springs. Thank you for joining today. I'm your host, Julie Anna, the Senior Marketing Manager for MW Components, Century Springs' parent company. For those of you who are not familiar, MW Components manufactures stock and custom precision metal components. Century Spring, one of our most well-known brands, offers the largest stock spring selection in the world, along with a robust custom manufacturing department. I'm joined today by our presenters, James and Ida from Century Spring. James has over 20 years of experience in stock spring inventory and applications, while Ida is an engineer by trade with over 15 years of experience in custom spring design and manufacturing. Before we begin the presentation today, I'd like to give you an overview of our agenda. Today's webinar is expected to last between 30 and 45 minutes. First, James and Ida will go over the presentation. Then we'll go into our question and answer session. During that session, you can get any questions that you have answered about specific applications, stock spring use, or custom spring design. We encourage your participation during that session and look forward to answering your questions. Once we've completed the Q&A, we'll go into a quick wrap-up and closing. As you think of questions during the presentation, however, feel free to submit them in the Q&A section at any time. You can access this by clicking on the Q&A icon in the bottom of the screen and typing your question into the box provided. Depending on the nature of your question, we'll either respond immediately or address your question at the end of the call during the Q&A session. I will now pass the mic to James and Ida to begin the presentation.
Welcome, guys. This is James Paisley. I'm the sales manager here at Century Spring out in Commerce, California. And today's webinar is really not just to define a stock spring versus a custom spring, but to kind of dive into the benefits and value of both and why you may be able to take a stock spring when you're thinking it needs to be custom and vice versa. And so with that said, we will get this thing going. Some of the topics we'll be covering are stock and custom spring overview, stock spring specification ranges and availability, how to determine whether or not you need a custom spring, and some design tips for custom spring needs. I'll be covering the stock side of this presentation, and then I'll turn it over to Ida and she'll pick up with the custom spring portion. So to differentiate the two, stock springs are probably exactly what you think they are. They come right off the shelf, they're ready to ship, and it's an effective and time-efficient way of testing, procuring, bringing in springs for immediate use. You really reduce lead time, setup fees, and a lot of excessive costs that go in to a custom spring. We manufacture over 40,000 parts to restock on our shelves. And so getting into some of the quality requirements, we provide a certificate of conformance with each shipment. We cannot provide a lot traceability with a stock part because we're constantly remanufacturing lots to mix on the shelf so that when the demand comes in from a customer, we're able to pull it off the shelf and ship it immediately. With each shipment, you also receive a RoHS and REACH certification. And all of the parts we manufacture and sell off the shelf here are made in the USA. As I mentioned a few minutes ago, one of the key benefits is the immediate availability. Of course, cost savings and a vast breadth of stock to test from. Oftentimes, an engineer or specifier may think they need a spring to this spec or that spec, and you can find yourself running down into a rabbit hole with spring design and manufacturing lead time, all to find out that's not the spring you need. The benefits really of pulling from stock is you are able to test a number of springs to see what may fit your application the best. And it's a real cost-effective way, whether it's trying a few different rates, different materials, etc. Additionally, using a stock spring can lead to a quick turn custom part. Oftentimes, starting with our stock catalog or searching a part online for candidates, you can find something that's very, very close to what you need. And then with our design help, with our engineering team, we can turn that stock part into a perfect custom iteration to satisfy your application. Sometimes you can't get what you need from stock though, and that's where you would turn to our engineering team and run down the path of a custom spring. So custom springs are made to order, whether you provide the specs, if we help you design it, or if it's a stock part that you need tighter tolerances or some small iteration to, that's what our custom team will do. The nice thing about Century is rapid prototyping. We will make just one spring as a custom here. And with that, you will get all of the lot certifications, traceability, raw material certs. Those are all available with the custom, which they're not on the stock side of things. We do inventory custom parts if needed, but in most cases, they're made to order. And current lead time for custom parts here, provided raw materials available, and there aren't an excessive number of outside processes, it's just 3 weeks, 4 weeks. So it's pretty quick relative to the industry. There are expedited options if needed. We've had many cases where a custom part can be designed, produced, and shipped in as little as 1 week. So, bear with me. So to give you a few ideas of the stock parts that we offer, I've got a slide here with some photos. First and foremost, our compression springs. They're probably the most popular when someone thinks of a spring. Secondly, would be an extension spring. We've got torsion springs, tapered or conical springs, die springs, disc springs, urethane springs, and constant force springs. Just to touch real quick, a tapered spring would be great if you have a confined space and you're looking to deflect that part to, in some cases, solid length. Die springs are really for heavier loads and lower deflections, often in punch presses. A lot of the die springs we sell are for MRO purposes. Disc springs as well are going to be in a confined space. These are designed for higher loads, lower deflection, and disc springs can be stacked in a variety of ways to achieve the load and deflection your application requires. Urethane, primarily off-the-shelf parts we offer here are for like a bushing type application. And then lastly, constant force is depicted. Constant force is, I guess, in layman's terms, a great point of purchase spring. So imagine when you're in the convenience store and you grab a Coke or a soda off the shelf and that next product slides forward. A constant force spring is what's sliding that product forward. And here's a slide on our catalog, which kind of works in conjunction with our website. It's a great source to search all of our stock components by specification. General specs that we call out both in the catalog and on the website would be outside diameter, free length, material grade. We would include a spring rate, a max load, suggested max deflection. For compression springs, we'll list a coil count. Some of the attributes do vary by category, but searching online with our search function, where you can enter a range of values, is a great place to pull all potential stock candidates as well as the catalog. And when this presentation is over, you guys will see my email address and contact information. Feel free to reach out if you'd like a free copy of the catalog. I'll be happy to send one out. So some materials for stock springs. Off the shelf, we specialize in a lot of the 300 series, primarily 302, 304, and 316. We do high carbon steel, music wire, hard drawn, oil tempered, and then a limited number of beryllium copper and phosphorus bronze. Those are more or less fewer demands for parts off the shelf. It really is the 300 series and the steel components or the steel material that people tend to pull. You'll see below this picture is just a little reference of how we inventory our raw materials, which is a fantastic part of the stock business. If we're out of stock or running low, having all the raw material on hand really enables us to quick turn and get parts back on the shelf. As a stock spring company, our goal is to ship 95% on time. And by on time, I mean same or next day. And when you think about 40,000 parts, that's a lot of inventory to keep on hand for that on-demand requirement. Off the shelf, some of the finishes that our parts come in are zinc, gold ironite or gold zinc, black oxide, an oil finish and dry film lube, also phosphate. And then not off the shelf finishes would be a nickel, gold, silver, and passivation and an electro polish. Those are secondary processes you would have to elect, or we offer a lot charge where we can add those to the stock component. Another thing about the finishes is if you find a stock part for your application and it's perfect and it's got a zinc finish or it's got a black oxide finish off the shelf, we can strip that for you upon request and refinish it or send it to you unfinished, however you see fit for your application. So we are flexible with altering the finish on the stock part. Some common questions that we come across when people are looking for a stock spring. This is quite common. Can I use a stock spring if you have a very tight tolerance for your application? Our stock parts off the shelf are certified to SMI commercial tolerances. Oftentimes people think they need a tighter tolerance than they actually do. And so really testing that part with a range of samples is a great place to start to see if the stock part will fulfill. If you do need a tighter tolerance, that's a quick modification and we can turn that over to the custom side. How do I know how strong a spring is? The strength of a spring is measured by its K or spring rate, and this is often translated to pounds force per inch. So an example, if you have a 5-inch spring with a 2-pound spring rate, for every 2 pounds of force applied, that 5-inch spring will deflect 1 inch. Next, is it safe to compress stock springs to solid height? In some cases, yes, and in some cases, it's not. Depending on the spring design and the suggested safe travel, it may enable the spring to go to solid length where all the coils are touching one another. But in most cases, for stock parts, you'll find that there is a safe load and a safe travel value. If you keep within that range and you don't exceed that safe deflection value, we would certify, more or less 100,000 cycles for our stock parts. However, if you go over that, you run the risk of fewer cycles as well as the spring taking a set. And by set, I mean the spring will deflect and then later not return to its original free height. On the flip side of that too, if you are deflecting it far below the safe travel and safe max load, you can exceed far more than 100,000 cycles for stock parts. Is the OD or ID more critical when ordering a stock spring? Well, we certify the tolerance by OD, but both are critical attributes, depending on if your spring is working in a bore or over a rod. You would want to ensure that you have a safe amount of tolerance so that the spring can move freely. In some cases, the commercial tolerances may comply with your application, and in others, you may need a tighter tolerance. Another thing too that we find engineers will consider is when it is working in a hole or over a rod, if they find the perfect stock part, oftentimes they can adjust their component rather than having to go to a custom spring, i.e. using a smaller rod or maybe enlarging the hole. So those are things that you can consider as well to accommodate a stock spring without having to go down the custom road. Can you grind a closed-ended stock spring? Yes, but the parts that come off the shelf from Century and any other stock spring company, we would say no. Our springs off the shelf come at a variety of ends. We have open ends, we have closed only, meaning the last coil is touching the second to last coil. And then we have closed and ground, where that last coil touching the second to last coil is ground flat, so it can stand perpendicular on a desk or a flat surface. The reason we don't take a stock part and modify it with the grind that currently has a closed only end is it will reduce the free length as well as potentially alter the performance and spring rate that we certify it to be from the catalog specs. So if either type of end is critical in your application, you would want to search the catalog specifically to that end or consider a custom iteration. Some recent stock spring cases that satisfied some great customer demand. We had a baby booster seat manufacturer that was not doing business with us, and they had been procuring a custom part from an alternate supplier, ran into a supply chain issue. They were unable to procure springs in time to finish the assembly on their baby seats, and so they contacted us. We provided them a range of samples, and within days, we identified a great stock candidate. The reason we were able to turn this around so quickly is because we had ample raw material. It was a part we had 50 to 100 pieces on the shelf of, and with the raw material available, we were able to turn parts around and deliver on time so they could finish their assembly and get that part and the product out to market. Secondly, there was a aerospace satellite application. When you think about aerospace, you often think about traceability, special materials, etc. But in this case, they were able to use any component that was made in USA, and tolerances weren't a big issue. They had a design change amidst their deployment schedule and were unable to procure a custom spring in time. So they came to us. We were able to, through sampling, we were able to identify a perfect candidate for their redesign. And again, having that material on hand, we were able to quick produce, ship and deliver in time, so it did not disrupt their deployment satellite schedule. So the common denominator in both cases is, if we don't have it available off the shelf, but we have the specs available online or in the catalog, there's a great chance we have the raw material behind it to turn it around really in any volume to get your parts quick. And so now I'm going to turn this presentation over to Ida, who's going to talk a little bit more about custom design, and how stock parts can transition to custom. So here's Ida.
Good afternoon. My name is Ida Machachi. I am the custom business development manager here at our Century Spring division. So as James already mentioned, if stock is always a very good start, but if it's not quite what you need, there are quick modifications that we can do to these stock parts with a very short lead time, manufactured as custom. Some of these changes can be changing the spring rate. We have customers all the time asking us, the spring works perfectly, I just need the rate to be 20% stronger or 20% softer. The max load, max deflection, we can change the material grade. For stock parts, we mostly use what we call standard materials, but we can of course manufacture these stock parts with more exotic materials. Or just simply, as James mentioned, going with tighter tolerances to make sure that they work inside of a hole or a shaft that you're using. Simply changing the main dimensions like the OD, ID, the freelance. And of course, last but not least, if you need full traceability, they need to be manufactured as custom. We can provide raw material certifications, mill certification, in-process, first article, final inspection report, outside processes. That can all be, even we offer PPAPs, we offer AS9102 first article inspections if needed. But if any of these are needed, it needs to be a custom order. So simply, if you have a print, or if you have tighter, meaning precision or tighter tolerances, if you have a complicated design, or if you need some exotic or specialty materials, we can manufacture these as custom. Sometimes, you know, you have a print, which is great, but sometimes this is actually our favorite scenario. The customer knows, all they know is that they need a spring and they don't know where to start. That's a great place to start with us, involve our engineering team. We can help you with the design and make sure that it is manufacturable and make sure that we're offering you the quickest lead time. Sometimes customers, they have a sample spring. They don't know what the material is. You can send us a sample spring or springs. We have a spectrometer here. We can analyze the material, understand what the material is. We have, of course, spring testers. We test the spring to get it to understand what the rate is, and we can duplicate that spring as a custom order. Here's a short video of spring being manufactured. Here's a very short, simplified overview of the spring manufacturing process. The first step is, of course, the coiling step. What we do here at Century Spring is all cold wounding, meaning we do not add any type of heat to form the material. The majority of the cost, labor, setup, labor and time goes into setting up the machine for coiling. We have the CNC machines, we have the mechanical coilers, and to give you an idea, for a very, let's say, simple compression spring, something that, you know, it's not too long, it's not, it doesn't have tight tolerances, it's just easy compression spring. We need at least an hour to 2 hours of setup. The run speeds are usually pretty fast. The next step would be stress relieving. Stress relieving in spring manufacturing is a standard part of the process, just because we, as I mentioned, is cold coiling. We form the metal by applying force. When you do that, you add stress to the material. So it has to go through stress relieving so we can release that stress. That is done in-house for our stock parts or some of our custom parts. We have the inline and the box ovens that are all, of course, calibrated, and they have heat charts. We can offer you for custom orders a copy of the heat chart that you can see the time and the temperature. But if you need beyond that, meaning you need NADCAP certifications for heat, meaning heat treat or stress relief, we can send them out to our NADCAP vendors, NADCAP certified vendors, and we have a whole bunch of them on our approved supplier list. The next step may or may not be grinding or secondary. Grinding, of course, is for compression springs. Secondary can be really any secondary operation like bending, flattening, forming, set removal that we do to the springs. Of course, our goal is to avoid secondary operations if possible, because they always add to the cost. And the last step, if needed, is finishing. We do not do any type of finishing or cleaning in-house. All of our springs are sent out to our approved vendors. You can also, you know, if you have your own approved vendor list, you can tell us what vendor you want us to send the spring to for, let's say, electropolish, and we make sure that that is done. We pretty much what we do, we reach out to your vendor and we add them to our approved supplier list, and we send your parts to them. So here's a spring design process. The first step would be defining the problem. What is it that we're trying to do here? Based on that, we decide what type of spring we need. Once we decided the type of spring, we need to know the environment, the the life cycle expected from the spring. Based on all these information, we select the material. we design to optimize. We check our design. We check that, if there are load points, we check the stresses. And sometimes when we check the stress levels, we have to go back and we have to change some of the parameters to reduce the stresses, sometimes even go back to change the material. So when we work with our customers, meaning engineering works with some of your engineers, we do this back and forth sometimes for a few weeks to get to that optimal design. We use the advanced spring design software that is used by most spring manufacturers. And we can even send you screenshots of the design sheet for your approval. So as I mentioned, the first step would be understanding what is it that we are trying to do. Are we trying to just apply a force? Are we trying to control a displacement or a position? If you're trying to accelerate or decelerate an object, or just simply trying to occupy a space. Once we know that, we have to see what the critical functional characteristics are. Is it the rate that is mostly critical? Do we have two load points, meaning the installed length and the cycling load point that is critical? Do we have constraints on the space, meaning do we have a max solid height requirement? Do we have a shaft? Do we have a hole? You need to make sure the spring fits into. What is the life that is expected from the spring? As James already mentioned, the minimum we design to is 100,000 cycles. Of course, theoretical values, right? Everything we do at the design stage is reviewing the stresses and reviewing the graphs, but we do not manufacture and design to less than 100,000 cycles. But if you need 10 million cycles, that needs to be communicated with us to make sure that is actually happening. The next step would be what type of spring we need. You see a picture of some of the very common springs. Of course, the most common is compression spring, which can have a constant or varied spring rate. James already mentioned they can come in open ends, closing round. Extension springs, they usually have a hook at the end, two hooks on each side, of course. At the ends, the hook orientation can be defined. They can have machine hooks, which is pretty standard, full loops, double full loops, side hooks, extended hooks. You can specify the hook orientation. I want them to be in line, or I want them to be 90 degrees to each other. You can specify the gap size for the hook. All of this, of course, can be done as a custom order. Torsion springs, they rotate at a constant rate. They can have open or closed wound. Actually, all springs can have open or closed wound, and that pretty much means if there's a gap between the coils or not. And of course, torsion springs, they can come with a variety of leg configurations. The angle between the arms usually is per-SMI, commercial is plus or minus 10 degrees. We can manufacture to tighter tolerances like 5 degrees, and in some cases we've done even tighter than 5 degrees. One other product that we do offer is double torsion springs that is not mentioned in here. Yeah, it's pretty much like two torsion springs attached through, attached by the middle. Tapered or hourglass springs, these are technically a type of compression springs. These are usually used when there's a space constraint. You've probably seen tapered springs in battery applications. The nice thing about them is if you compress them all the way to solid height, of course, if they're not overstressed, it can nest stitch into itself, and the solid height becomes equal to one wire size, which is pretty nice. Next step would be picking the right material for the application. On this table, you see some of the very common materials that we use. Music wire is the most common one. Great material, high tensile properties, relatively cheap, comes in variety of sizes. The only issue with it is, of course, it's high carbon steel, so it's not corrosion resistant. Of course, we can add different types of plating to it, like zinc plating, which is the most common. Next would be 302, 304 stainless, 316 stainless. 316 is the food or medical grade stainless. It's softer than the rest of the materials in here, but great corrosion resistant properties. 177 is my favorite type of material. It has high tensile, it has corrosion resistant, it's mostly available in a variety of sizes. I see that, you know, we have like cost as red. I mean, again, of course, it is more expensive than music wire, but relative to more exotic materials, it's still not that expensive. And of course, we use all types of metals. If these won't work for you and you have a very specific application, we can use the exotic materials such as Elgalloy or Finox, Inconel for high temperature applications, chrome silicon, Nice-Pan, duplex, and more. Here are some tips on what to watch for when designing a spring. This graph is something that at least once a day we discuss with our customers, which is very, very important. It's important to know that the linear range of spring rate is within 15 to 85% deflection, meaning less than 15% deflection, as you see, it's not linear, and beyond that, which gets very close to the solid height, is no longer linear. The reason for it is you need to have, so let's say a compression spring. On a compression spring, the last coils at the ends are called dead coils. The coils in the middle are called active coils. So when we compress, let's say compression spring, we need to have enough deflection so the active coils start moving. And similarly, on the other side, if we compress the spring too close to the solid height, now the dead coils are moving. Now everything is moving. So the rates can go out of, you know, it's just the measurements won't be accurate. So we try to avoid, you know, specifying load points less than 15% and higher than 85% deflection. Obviously, you know, we have to try avoiding high stress designs because that directly affects the life cycle of your spring. If a spring is overstressed, usually the term that we use is it will take a set. As James briefly mentioned, it simply means it gets shorter. There are ways around it in spring manufacturing industry to reduce that stress. One of them is presetting. What presetting is, simply manufacturers manufacture, let's say, compression spring longer, and they preset it, meaning compress it to solid height or to a specific load point 3 times, at least 3 times, to take the set out. And as you can imagine, it's extra secondary work, so it definitely affects the pricing. So we try to avoid it if possible, especially for really, really large quantity orders, because it can drastically increase cost. But it is important to know that not all springs can be preset. It really depends on how overstressed the spring is. If it's extremely overstressed, presetting won't work. Next would be index. Index pretty much, as you can see, we have a 4 index spring and a 12 index spring. We've tried that it really is how tight the coil is wounded. We don't want to go with super tight index because it's hard to coil. It damages the machine, it breaks the arbors, it increases the setup time. And on the other side, we don't want to go with super light, large indices because simply they become very unstable and imagine like a slinky. So it's very hard to get readings of rates and loads with very high index. Of course, we have to always know the environment the spring works in, if it's like, you know, acid environment or base environment, or, you know, if it's medical, if it's in touch with the patient. These are all very important. Also the temperature, you know, for oil and gas industry, we use lots of Inconel because of the high temperature needed. So these are all the points that needs to be discussed with the customer. Tight tolerances, engineers tend to over-design and over-engineer. I can say that because I'm an engineer. We tend to sometimes over design our what we design, and it's not always needed. And I know that for a fact because I've had conversations with some of our customers when we ask if this is really needed, the answer is no. It's important because the tighter the tolerance, the longer the setup time. The longer the setup time means higher cost, means longer lead time, and sometimes extra secondary operations. So we want to avoid that if possible. One important point is block tolerances that you can usually find on the prints on the bottom right side of the print do not apply to spring manufacturing. We manufacture to SMI tolerances, precision or commercial. Block tolerances are for machining. Buckling is another thing that we have to watch for. You can see a picture of, exaggerated of course, picture of a spring that has buckled. Usually when the free length is larger than 4 times the OD, spring buckles. So you can imagine it's very hard to get readings when we test these springs because it goes sideways, and sometimes we do some tricks to to help us measure the spring rate or loads. Let's say we put a shaft inside the spring to hold it stable, but that's something that we try to avoid. Squareness tighter than 3 degrees. 5 to 3 degrees is pretty standard in spring manufacturing. We've done tighter than 3 degrees. We've done 2, we've done 1.5. But again, we have to know if it's really, really needed, because anything tighter than 2 degrees is extremely hard to manufacture. And of course, larger than 5 degrees, you can see just, if you look at the spring, you can see that it's kind of like tilted. Tool marks is, I would say you can't avoid them. You can definitely reduce them and minimize them. So when designing a spring for you, we have to know how critical the tool marks are for you. There's always a cutoff mark, right? When we cut the spring at the very last coil, you see the tool mark. When we bend, especially tight bends on torsion springs, you can see the tool mark. So it's important to know how critical this is, because we can do things to reduce and minimize tool marks. Extremely fine surface roughness. For closing ground compression springs, sometimes on the prints we see there are call-outs for very fine surface roughness. It's doable, we do it all the time, but it's important to know that if it's not needed, it needs to be avoided, because let's say if a regular compression spring with closing ground ends should go through one process of grinding, a spring that has a very fine surface roughness requirement should go through multiple grinding operations. And as you can imagine, that can increase cost and lead time. Open ends, you see a picture of an open end compression spring, unstable. So if you need to measure and tolerance loads and rates, we try to avoid open end springs. High pitch angle. Pitch angle pretty much is the angle between the 2 coils. Let's say in a compression spring, usually the max is 15 degrees. If it's higher than that, it becomes unstable and overstressed. Less than 4 coils. I already mentioned the 2 coils at the ends of a compression spring are called dead coils. So let's say we have a spring with only 4 coils. That means we only have 2 active coils. So we're not really giving the operator any room to modify, add, or reduce the number of coils to get the load and the rate right. Also, we only have 2 active coils and 2 dead coils. Again, there's a high chance that when we compress the spring, everything is moving. So even for our stock parts, the springs that have 4 or less coils, the rate value is just a reference value. Combination of too many processes with tight tolerances. This does happen with aerospace mostly. As you can imagine, if we have too many secondary operations and outside processes, along with very, very tight tolerances, every time we do a process on these springs, we do something to the spring, right? We preset it, we reduce the material with the grinding. Every time we do these, the tolerances may or may not go out of tolerance. So if of course, it's unavoidable, right? We have to do some of these processes, but if that is a requirement, try to at least make the give us enough tolerance so we can make sure that they stay within tolerance. 100% inspections, we do them all the time, but again, as you can imagine, can be very costly. There are critical dimensions that customers require us to do 100% inspections. We have the most advanced and the latest inspection machines in our inspection room, so they're pretty fast. But even with that, it can drastically affect the cost and the lead time. Tangling, you see pictures of a spring that has tangled. We call these bird's nest. It usually happens when you have a high pitch, high index, open ends springs. Sometimes we can't avoid it. We can do special packaging for it, as you can see on the right-hand side. But again, special packaging can be costly. Here are very general tips on the tolerancing. But again, tolerancing all depends on the spring design. So these are just very high level, just suggestions. So for the cutoff burr, leave 10% of the wire diameter. If you have two loads that they need to be toleranced, the rate and the free length should be reference values. I mean, we can't really tolerance everything, right? We have to understand what is critical and what can be a reference value. If the rate is toleranced, only one load or the free length can also be toleranced. Coil counts, unless the spring should be manufactured to physical dimensions only, for the most part, coil counts should be a reference value. And of course, try to avoid tolerance stack up. Some of the typical tolerances for the wire diameter, really this one is out of our control. What we do not make changes to the wire size. We buy the raw material, and all the material that we purchase are from our approved suppliers, and they are per ASTM and AMS standards. Body diameter, which is the OD, or the mean diameter, can be, depending on the design of the spring, can be 3 to 10%. Free length, again, depending on how long the spring is, it can be 2 to 5%. Loads and rates, plus or minus 10%, we can manufacture as custom, as tight as 5%, and sometimes even tighter than that. But what we really, really ask our customers is that if you don't have a print or you're thinking of designing a spring, let us know in advance, involve our engineering team. Let the engineers of both sides discuss what's needed so we can offer you a design that is manufacturable and offers the best lead time. Because there are cases that, we even receive a print and it says, what the wire needed is 0.162. What we have in stock is 0.16. Changing that wire size won't really change the design that much, let's say. If we discuss that in advance, we can offer you a custom manufactured parts maybe in 10 days, whereas if you have to go buy 162, it may take 6 to 8 weeks. So it's very important to involve us from day one, so we ensure manufacturability and the best lead time. Here are some of the questions I received during my last webinar. I wanted to bring up here. Why is my design overstressed, and what does it actually mean for manufacturing? Well, the spring being overstressed depends on so many factors. Of course, I already mentioned there are ways to reduce the stress, like presetting and shot peening, but it really is hard to just say why a spring is overstressed without seeing the design. And what it means for manufacturing, by all means, we can manufacture a spring that is overstressed. It's not going to be the life cycle you expect from it. Will my spring buckle after preset? Well, buckling and presetting are two different things. We already discussed both. So the spring that buckles, when we preset it, it buckles again. So it's not a good scenario. Why does my number of active coils need to be treated as reference? I actually just discussed this. We need to have, again, enough room. So the things that control, let's say, spring rate in a compression string is the wire size. It's the OD, or the mean diameter, or the ID, depending what's critical, and the number of coils. So the wire, we can't really change the wire size, let's say, when we pick the wire size. So we have a little bit of tolerance on the OD. So the only parameter that we really can work with mostly is the number of coils to get the rates in. I want to use Elgeloi. Why does it make it more expensive and have longer lead times? Elgeloi is we consider it an exotic material. It's a super alloy. It's a trademark. It's manufactured by Elgeloi, the company. So of course, when they own this material, the lead times are usually extremely long. And of course, it's more expensive because it's a super alloy. And with that, I'll hand this to Juliana.
Thank you, James and Ida. We do have some time for questions, so please go ahead and start entering those in the Q&A section if you have any that were not entered during the call. We can address those and everyone can learn from our presenters. If you have questions of a proprietary nature, you can send an email to our presenters and they'll be happy to answer those questions privately. Their contact information is shown on the screen now, so if you want to save that for later use, you can. We do have a couple of questions submitted during the call, so we'll go ahead and get started there. Our first question, on a closed end only compression spring, what percentage of the end is flat as compared to a closed and ground end?
So on a closed only spring, it's not flat. If you need flat ends, we have to grind the ends. You can actually specify the width of the spring. Of course, that's custom. There are prints that I've seen that customers said, do not go lower than some percentage. But what we want to make sure is that to not overgrind or make the last coils too thin, because I've seen that happen, and during the application, especially like cyclic applications, that the ends just like break really fast. So I would say definitely not, we don't grind more than half of the wire size.
Great, thank you, Ida. Our next question, how do you grind springs during manufacturing?
So we have the grinding machines. If I want to explain how it works, imagine there are plates that have, we call them grinding plates, and there are holes in them, and these holes match the OD of the springs. So we put these springs into these holes, and then there is a grinding circuit, and these rotate, and then the grinding machine, if you will, again, sorry, I'm not a manufacturing engineer, as they rotate, they grind the ends.
Great. Our next question is, was music wire literally made for music originally?
You are absolutely correct.
Perfect. Our next one, you stock electroplated springs. What are your processes to reduce the risk of hydrogen embrittlement?
So as I mentioned, we do not do any type of plating in-house. We send all the outside process, all the platings to our approved vendors. They are the experts, and they make sure that that does not happen. So it has to do with the heat and how much they are heated, I think, after the plating. I can give you very detailed, because recently we had a customer asking this, and since we don't do platings in-house, I had to go back to our vendor and ask step-by-step processes that they go through. I can share that with you if you're interested. You have my email here on the screen. You can email me and I can send you what the vendor sent me. But there are materials that they're more prone to hydrogen embrittlement, for example, oil tempered. But even for oil tempered, there are ways to avoid that. But I've seen when a spring is hydrogen embrittled and it's bad. We just dropped it and it turned to like pieces. But yeah, our vendors make sure that through the heat process, make sure that that does not happen. But if you need more details, I am more than happy to share it with you.
Great. Our next question is, can you give examples of applications for variable rate springs and how they differ from regular compression springs?
Examples. Off the top of my head, I can't think of an actual application, but I can tell you how it's different. So regular compression spring, at any point you compress the spring, you should get the same rate. So, you go to our website, says compression spring, the spring rate is 5 pounds per inch. At any point, of course, as long as you're within the 15 to 85% deflection, at any point you will get 5 pounds per inch. But when we have variable rate, and that's usually, we get that through varying the pitch. And we actually do have, even in stock, we have some variable pitch tapered springs. So in this case, on every different points of deflection, you get a different rate. So I can't think of an application right now, but that's what the difference is.
Thanks, Ida. Can you explain the relationship between free length, solid length, pitch, and number of coils and the diameters of the coils?
Not sure if I understand the question. Is that what is defining what each is, or
defining them, and perhaps if there's any interconnected requirements between them?
Can you tell me which dimensions they're?
Free length?
Okay, so free length, I'm just going to use a compression spring as an example, right? So free length is the length of the spring from one end to the other end at a free state. Solid length, when it's compressed all the way down to solid, meaning all the coils now are touching. Pitch is the distance between one coil to another. To be more exact, it is measured from the mean diameter. Mean diameter is, we have the outer diameter, we have the inside diameter. So OD plus ID divided by 2 gives you the mean diameter, meaning the diameter that you see on the center of the coils, center of the wire. So that distance is called pitch. Number of coils is simply how many coils your spring has. The way it's measured, let's say for a compression spring, the first half coil and the coil after that is counted as 1. And then you continue counting the rest of the coils all the way till the end. So let's say at the end, you have another half coil. It becomes, let's say, 5.5 coils. You have a quarter of a coil, becomes 5 1/4. So the relationship, I'm not sure if I understand the question, but of course there is a relationship between number of coils and the solid height, right? The more coils you have, the higher your solid height. Free length and I'm trying to find a relationship between these. Yeah, I mean, free length and coil count, I guess the only relationship would be we need to make sure that we have enough coils so we don't end up with a high pitch.
Thanks, Ida. I think that was really helpful. We do have a couple more questions before we reach the top of the hour, which is the end of our time today. So our last three questions are, is there a minimum number of springs required for a custom order?
We do not have a minimum quantity. We can manufacture, and we have as many as one piece. But again, as I mentioned, the majority of the cost comes from setting up the machine. And either you order one piece or 1 million pieces, we're setting up the machine. So you can as you can imagine, the price is highly quantity sensitive, right? So the higher the quantity, the lower the piece price. So it just makes sense, of course, if possible, to go with a higher quantity for the best price per piece.
Thanks, Ida. Can your stock parts replace those from other suppliers?
Yeah, in many cases, we do have similar stock spring attributes that do cross to other suppliers. Oftentimes it's another supplier, or it's not uncommon that a spring is designed and it just virtually matches something right off the shelf. But if you had a Lee spring, Associated spring, Ajax spring, WB Jones spring, print or specs, in many cases, we can cross right off the shelf to those parts.
Great. And our last question today, we might need to get back to you on this, but let's see if our presenters have an answer. Do any MW plants make wrap springs for wrap spring clutches? They have very tight ID tolerance on the close wound coils, so it can clamp tight on a shaft.
We have to get back to you on that. I haven't heard of, honestly, a wrap spring.
Okay.
Yeah, if there's a specification or a print, we can certainly stipulate that.
Okay. So to that requester, we will get back to you. We do have your name and email, and we will get back to you with a more detailed answer. We do have one last question that came in for our last 2 minutes. Why is the solid length not considered the max loaded length?
Because if I understand the question correctly, we cannot tolerance a load at solid height. The reason is exactly going back to the graph I just showed you. The rate is only linear between 15 to 85% deflection. When we go beyond that, close to solid height or at solid height, we cannot really tolerance the load at that point because it's no longer linear. And as I mentioned, again, at solid height, now the dead coils are moving and it just can't be toleranced. We can always on our quotes give you the calculated load at solid height, but that's something that is just going to be a reference value.
Great, thank you, Ida. That does conclude our time for today and covers all of the questions. I want to thank James and Ida for the presentation today. We will be following up with an email and a link to the recording so you can share that with your peers or use it for reference later. If you'll go ahead and navigate to the next slide for us, James. Just as a quick wrap up, Century Spring is one of the largest suppliers of stock springs worldwide. They do offer over 40,000 spring designs in stock, which translates to millions of parts that are available for same-day shipping. Both Century Spring and Century's parent company, MW Components, offer custom spring manufacturing as well. And MW Components offers a wide range of manufacturing for other metal parts, including fasteners, metal bellows, shims, and more. For more information on Century Spring, please go to centuryspring.com or go to mwcomponents.com for more information on MW. This does conclude our webinar. Thank you all for listening and have a great day.